Hello everyone, in this session we are going to learn about semantic memory, how semantic memory capability can be added to AI agent, and here we are going to use a LangChain Ollama as a local LLM, and we are going to use one of the vector database, that is PG vector. This runs on top of the PostgreSQL which we have used in the previous. If you have not watched the previous session, link is given in the description, you can go and watch it. Topics covered in this session are what is semantic memory in AI agent and how it works. Some of the real-time example we will see here, and after that get into a coding implementation of semantic memory, how we can plug in the semantic memory with the existing AI agent which we have learned in the previous session. First thing is, what is semantic memory? Semantic memory works exactly like a brain. As a human, how we remember things is we remember based on the keywords, not on the sentences. Semantic memory is the ability of an AI agent to store, organize and retrieve knowledge based on the meaning rather than the exact keyword or exact conversation history. Some of the key points here is stores fact, references, experiences, domain knowledge as a vector embeddings. This is very important. Instead of using the normal database, it uses the vector embeddings here. Retrieves the most relevant information based on the meaning similarity. Persists across sessions and conversations. Complements short-term memory. In the previous session, we have learned about how to store the conversation history in the PostgreSQL. It is a plain database and how AI can retrieve from the database. But this is different. It, instead of storing it as a conversation history, it stores as a vector embeddings, enables personalized, consistent and context aware responses. So what is the exact difference between the semantic memory and the short-term memory is? Short-term memory is stored in the checkpoint wise. Whenever we are saving anything in the database, we are adding a checkpoint, but semantic memory is stored in a vector database in a form of vectors. Short-term memory stores data within single session or a thread. This is the first type of a short-term memory. Across sessions and threads, this will be remembered, and it is sequential and time bound. Short-term memory is like remembers what was just said, but semantic memory remembers important knowledge and the fact. It is not going to store everything, it stores only the required information and important things. So let's see how it works. As a user, if I share some information with AI agent, what it does is it first converts into embedding. Text is converted into embedding, that is numerical vector, using embedding model. Here we are using one of the Ollama embedding model. You can use any other embedding model. There are multiple embedding models available in the market, and once it generates embeddings, it stores in the vector database, that is PG vector here in our example. After that, when user asks any question, that query is embedded and compared for the similarity. It goes to the database and checks for similarity, whether it is matching with the existing data or not. If it is matching, what is the best match? Then it will retrieve the information and shows to the user. This is how the semantic memory works, and in this example we are using LangChain Ollama, and this is running in our local machine, and the PG vector, this is for embeddings, and PostgreSQL. This PG vector is the extension of PostgreSQL. To implement the semantic memory, we need a PG vector and the PostgreSQL both. Let's see in detail. As a user, if I say that I love cricket, and memory extracts this particular information, that is nothing but the LLM, it checks whether is it worth saving, is it worth remembering. If answer comes as yes, then it will create the embeddings for the message what user has passed, and it will store it in the PG vector database, or it could be any of the vector database. Then when the same user asks a question, it goes to the database and retrieve the information, then it produces the result. For example, user says that my name is Pawan and I work as a software engineer, I live in Bangalore, I love cricket, what is weather today? For all the first four conversation, LLM decides that it has to be stored, and the fourth conversation, whatever happened here, what is weather today, it decides that it is not important to save it because weather keeps changing. This is how the LLM comes into picture. Whether to store this particular information in the database or not, it will decide. Only the important and meaningful information is stored in the semantic memory. So how it gets stored is, and each conversation is tagged with the user 1, and whatever the message user passes, embeddings will be generated and it creates as per the date. For similarly, for other messages also, it stores in an embedding format and stores according to the date. So what is stored here is important fact as a text, its vector representation, that is nothing but the embeddings. Metadata like user ID and the timestamp will be saved. The third step is, if user asks what sport do I like, then this particular message or the question or the query will be converted into vectors. These embeddings will be passed to the vector database, that is PG vector here, and on top of that particular question, it will go and search for all the semantic memories whatever is saved. It will pick top list from the vector database, and for each it will be having some score. Whichever is having the highest score, that data will be retrieved and showed to user here. So here hobby is saved as a cricket, and when user asks like what sport do I like, it says that 0.92 is having, this is the highest score for hobby is cricket, then that will be picked and sent to the user. Semantic Semantic memory allows AI to remember who you are, what matters to you, even across different conversations and days. Let's see a little more realistic example here. Assume you have a travel AI agent. How it talks to you as a AI agent is, user start chatting with the AI agent. I love beaches and tropical places. Then that information will be saved in the semantic memory. I prefer direct flights and 4 to 5 star hotels. My budget for international trip is around 1,50,000 rupees. All information will be converted into embeddings and it will store the information. What it stores is beaches, tropical, direct flight, 4 to 5 star hotels, and what is the budget. These all converts into embeddings and it will store. These have the information what user passes. It goes through PG vector and it stores like this. Then the third step is user asks question like plan a 5-day international trip for this December. Agent searches the semantic memory and finds your relevant preferences. From the database, it fetches these information. What the information is, loves the beaches and tropical places, prefer direct flights and 5-star hotels, and what is the budget. All these details will be fetched by AI agent. Using these memories plus real-time data, AI agent will give you an answer. How the answers looks like is, here is your 5-day trip plan this December based on your preferences. Destination is Phuket and Thailand. Direct flights details from a Delhi. 4-star hotel activities based on the information what we have sent. Based on that, it is suggesting these activities, and estimated budget is within the budget what I have sent before. And what is the recommendation? Remember that you love beaches and tropical places, prefer direct flights, 4 to 5-star hotels, and all the details. That is why I picked the Phuket place for you. And continuing that, what of the information which you keep passing to AI agent, it keeps storing into a database in a form of embeddings. It could be like destinations, hotel which you preferred, activities which you enjoyed, and new budget changes. All that information will be saved in an AI agent in form of embedding. Now let's get into coding part. We will implement all those things whatever we have learned so far. First thing is you need to pull the nomic embed text. This is the embedding models which is coming from Ollama. To pull that, this is the command Ollama pull nomic embed text. Go to terminal and run this particular command to pull the nomic embed text. It will take some time to pull it, and after that if you run Ollama list, it should show in the terminal about the nomic embed text. Next thing is a Docker or a Colima we need to run. If you are using a Docker, no need to run the command, and if you are using a Colima, you need to run this particular command. In the previous session I have shown how to do a Docker setup. If you are using Colima or if you are using a Docker setup, follow these instructions. And as I am using a Colima here, I'll run this particular command. Go to terminal and run this command. It says that already it is running. Now I need to update the requirement.txt to include the PG vector here. Go to requirement.txt and add a PG vector here. I'll add a PG vector. Then I will add langgraph checkpoint Postgres. This is another library for Postgres. We need to update the compose.yaml file to include a PG vector here. Go to compose file here. In the previous session we were using Postgres image here. Now we need to add the PG vector image which includes the Postgres plus PG vector here. I'll write a PG vector and this is the image name. This includes PostgreSQL plus PG vector extension. Now I need to run this docker compose command. Let me go to terminal and run this command. Instead of docker compose prod, it is just a compose file name. And once I run this particular command, it will pull the image and create the container. Then go to terminal and run docker ps command. It should show the container which is running here. Let's write a code here. This is the code which we have written in the previous session for persistent memory. We'll copy the same thing and change the file name here, AI agent semantic memory. First thing is a DB URI. This is for PostgreSQL. Is the username, password, and the database name. Then vector database URI, I need to add it here. This is the URI for vector database. Then I need to create an object for creating embeddings here. I'm using Ollama embeddings, and inside that I need to pass the embedding model name which I have it here. Model equals to then model name. This model name I can get it from my terminal here. If you go to terminal and run Ollama list, it should show you model name here. Copy the model name, that is nomic embed text here, and add it here and assign this embedding to one of the object here. Then I have to create a vector store object here by using a PG vector here. Vector underscore store equals to PG vector, and inside this PG vector I need to pass some of the details here. The first details will be embeddings. Whatever the embeddings which is coming, that I'll be adding it here as an embedding. Next thing is a collection name. What is a collection name? I want to give it here. I want to name it as semantic memory. This is the database name which I want to save it with. And next thing is a connection. Here I need to add the connection URI which I have declared above. Connection equals to vector DB URI. Then I need to add one of the flag here, use JSON or not. So use JSON and equals to true. Looks like there is some error here. Okay, this should be a collection name instead of connection. Okay, cool. So vector stored object is ready now. Let's scroll down, and here I need to add one method for saving the memory. Let me create a method called save memory, and this save memory takes two parameters. One is memory and another one is a user ID. In PG vector database, whatever the memory is coming, I need to store in a form of document here. That's why I'm creating a document document object. Document, this takes a memory, and what is the metadata, that is nothing but the user ID. And whatever document which I am creating, that I need to create it as a object here. Assign this to a doc object, and that doc object I need to add it into the vector store DB. So this is how I am adding into vector store DB. This vector store is defined above. After that, I'll add one more tool here to recall the memory. Add tool, and I'm going to create one method called diff recall semantic memory. This is my method name here, and this particular method will take the user query and it will hit the vector database, and then it will fetch the related information from the database. So this method is taking query as a parameter. After that, it is going to use a vector store database. Then it is calling one of the function similarity search. For that, it is passing the query as a parameter, which is nothing but the question which is coming from the user, and whatever the result it gets, it has to take top 3 objects here, top 3 results from the results, and after that then apply some filter. Filter is nothing but the user ID here. Database could contain many messages or many information. Out of that, I am going to fetch only the information or the results which are related to specific user ID. If doc object is empty, that means if it is not finding any of the relevant information from the database, then I'm going to return that I did not find anything from the database or the memory. Then if it is not empty, then return the entire doc object. Here I'm using a for loop. From entire document, fetch each doc and fetch the page content, then join with using a dot join and return the entire string. Then coming to a tool section, I need to add the tool name here, whatever I have created a new one, that is recall semantic memory. I'm adding in this particular list. Coming to the system prompt here I need to change the system prompt as we are using a semantic memory and the new tool. This is a system prompt which I have created. It says that we have two types of memory. One is short-term memory, another one is a long-term memory, and here I'm mentioning that use recall semantic memory whenever the user asks about it. References, previous projects, technology, background information, anything learned in older conversation, all these details I'm mentioning it here and adding in the system prompt. We don't need this prompt template. Let's delete this prompt template from here. Now let's come to main part here. Before querying, I need to add some information in the memory. For that, I will be writing some code here, and I need to call the save memory function, and for that save memory function I need to pass different messages which I want to save it in the PG vector. First message which I have added is I like Python programming and AI development. Second message which I have added is I have experience with web development and Django. Third message is like what I like. Fourth message is about what is my background. Fifth message is about what I am interested in. I am interested in creating YouTube videos on programming language and different technology. So to showcase, I am feeding all this message into PG vector database before asking the actual query, and all these messages which I am passing will be saved in the PG vector database. Then the remaining part will be same. I just need to change my question here. I'll come to this run agent part, and then I'll add a new question here, and to my AI agent I will ask a new question. What is the programming language which I like it, and what are the different interests which I have it? This will be my question to AI agent. The coding part is done. Let me go and run this AI agent. It is running the AI agent as it is running in the local machine. The Ollama which we are running in the local machine as LLM, it is taking little extra time. This is a user query which I have asked for, and here it is giving me the result. Yeah, it gave the result. Looks like it gave the result of the previous message also. Before this session I have passed some messages. Looks like it is retrieving all the information. If you take a look on the last part, so what are the different tools it got called, and this is the tool call section, and it says that called the recall semantic memory tool. And here if you take a look, it is fetching the top 3 results. Top 3 results are these. I have saved 5 messages, but it is fetching only the top 3 results, which is more relevant. And out of these top 3 results, it is fetching one result. Why it is fetching the top 3 result is here we have configured k equals to 3. That's why it is fetching 3 results. If you are adding more information and if you want to change the top 3 result k value, you can change it. So based on my results, it is clubbing all the information whatever I have saved, and it is giving me a final answer. This is how the semantic memory works in the AI agent. As I am using the local LLM, the answers and the creativity and the accuracy will be little low compared to live LLM. I'll commit this code to the GitHub repository. You can try it and let me know if you have any questions. Thank you.